and welcome to AETA Talks, the official podcast of the American Embryo Transfer Association. I'm your host, Kelsey Savell, helping lead the promotion committee with Dr. Ramon Tosta. Ramon, do you want to introduce yourself?
Yes, I'm one of your co-hosts, Dr. Ramon Tosta Duarte, AETA Promotions Committee co-chair. Great to be with you, everybody, today. We've got a great show for you today, and are thrilled to have three very special guests joining us. Two of them are from Genesis, Dr. Carol Wells, CEO and founder, and Mike Aree, embryologist and advisor, are here to discuss the work Genesis does and provide their insights on cutting-edge development in embryo transfer. We're also joined by Dr. Brad Lindsay, a longtime ATA member, who will bring his critical perspective and challenging questions to ensure we thoroughly investigate Genesis claims and methodologies.
And if you enjoy AETA Talks or have any feedback for us, please feel free to let us know at aeta@assochq.org. And make sure to like, subscribe, and rate us on whatever social media platform that you're currently using, and spread the word to invite friends and colleagues.
We'd like to give a special thanks today to our sponsor, Genesis. Genesis is a revolutionizing livestock reproduction with its innovative embryo health analysis platform using proven machine learning technologies. Genesis provides objective, data-driven embryo evaluation that helps producers select the healthiest embryos for them to transfer. Your support enables AETA to continue sharing valuable insights and conversations that advance our industry. So today we're going to start with talking with Kara. The first question will be towards her. And Kara, first of all, please introduce yourself. And following that, what inspired you to start Genesis? Was there a specific moment or challenge in your career that sparked this idea?
Thank you so much. Really appreciate you all including us on this exciting podcast today. So a little bit about myself and my background is I'm from the Houston suburbs, grew up in Missouri City, Texas, and I wasn't really familiar with this industry at all until I started college and started doing undergraduate research in reproductive physiology. And once I saw the science and embryos and ICSI, I was completely hooked. I thought it was some of the most fascinating stuff in the world, and I wanted to learn more about it. This led me pursuing a PhD in reproductive physiology, studying embryo selection techniques. This started about 15 years ago, and at the time, I was actually working on a specific gravity device to evaluate embryos. It was pretty cool studies. We found out that when you dropped embryos through a fluid-filled chamber, the ones that sank like a stone were actually non-viable and did not go on to develop like the embryo counterparts that would drift slowly or even flip. So this was all really cool for academic purposes, but was really interesting is at the time I was doing 100% of my research on mice, but I had peers in the animal science department that were like, hey, what you're working on is really interesting. My veterinarian's coming over to transfer some cattle embryos or some sheep embryos. Would you want to come use your device on these embryos at our farm? And so I did, and we were able to create some publications out of that. But what I realized in this process was that my friends weren't just being nice to me. They weren't taking the risk on their embryos on their expense because they wanted to help me graduate, but it was because that they wanted solutions to improve live birth outcomes of IVF and embryo transfer that could be accessible by then. Long story short, I had a lot of some hard learning lessons along the way, especially as I learned more about the industry, practical, commercial side of IVF and embryo transfer, when I realized that products didn't just need to achieve accuracy, but they needed to be practical, affordable, and fit into the workflow of the livestock embryologist or embryo transfer practitioner. And so I really dwelled on this for several years, wondering how can we create more objective, non-invasive solutions that could work in this industry. And the aha moment came one day in 2020, right at the start of COVID, which I'm sure we all remember quite well, when I realized that advancements in computer technologies and machine learning were starting to transform all aspects of our life. That why haven't we applied this to livestock embryos yet? And by not doing so, it was truly a missed opportunity. And so I took the notion that if embryos are living, growing organisms, do they have activity that can be captured in short real-time videos? And can we use machine learning and artificial intelligence to evaluate that activity and outperform what the best embryologists in the world could see with the human eye and brain? So 5 years ago, this was a research project. We've been collecting data ever since, and then building upon these solutions and evolving the product so we can create objective analysis of embryo health in real time.
That's awesome.
That's great. That's great. Kelsey, if you want to go ahead.
Yeah, I was just gonna, just so we can get, everybody kind of introduced. Michael Wright, can you kind of comment on some of your background, introduce yourself a little bit, and then also just tell us like how you're involved with mGenesis?
Yeah, I've been around ET my whole life. My dad's has a practice in Colorado, so I grew up giving donor shots, whatnot. Um, Quite a bit of experience transferring, collecting. Um, I went on my own back in like 2019, similar to when Kara started this. And I get frustrated, the pregnancy rates have been kind of stagnant for a while. I mean, these IVFs have improved quite a bit in the last few years, but I do think I am a believer in technology, and I mean, the next step is to leverage this technology to improve pregnancy rates and ultimately live calf outcomes, and you know, for the clients, and just to push genetics forward in the beef and dairy industry. So, we need to use whatever technology we can. And so I met Kara, I forget what year it was. I think it might have been 2019 in Colorado Springs at the AETA, and we kind of kept in touch. And she told me about this. That was when she was working on the gravity. But then she reached out to me a couple years later and like, hey, I got a new project. Looking, what do you think of it? We need some more data. So I slowly got involved, and then have provided quite a bit of the data to train the models and test all the systems and everything.
That's awesome. That's awesome. Dr. Lindsay, would you like also to introduce yourself, please, and then just tell us what you know about this technology, or if that's the first time you're hearing about it.
Sure. Yeah, no, thank you for the opportunity. It's a welcome invitation that I accepted readily, because I pretty much spent my entire career in embryo transfer. I've been in the business now for 42 years, if you can believe that. But I started out with the old Granada Corporation, first doing equine repro and embryo, and then migrated over to the cattle division. And it was a great opportunity to see all the technologies that we were using and trying to implement practically in the industry in the 80s, including being the first domestic company to commercialize IVF. And so it was very exciting to me to be part of that, and then move on to the commercialization, from the commercialization with IVF, finding that there's a lot of problems, obviously, and just trying to work through those issues, and realizing that we have so many challenges with IVF embryos. They're not the same, as we all know, and then trying to find solutions to that. And I've like I said, spent most of my career trying to solve some of these problems. And I think initially we realized that we were going down the wrong street in terms of, looking at embryos and trying to figure out why IVF embryos wouldn't freeze. Well, some of the early, attempts to alter that, outcome was to try different methods of freezing. And I always held back from that, realizing that we probably needed to look at building a better embryo to freeze. But it all comes down to evaluation, right? And we have a lot of subjectivity with technicians. We have the subjectivity now between in vivo and in vitro embryos. And so it's, there's been other attempts, I guess, at looking at how can we integrate, different technologies to evaluate embryos. The human eye is amazing, but microscopes can duplicate a lot of what, and then it's analyzing the data. I think that is, one of the things that, and I have worked with Kara and, their team in terms of collecting some of the data. We didn't contribute a whole lot, but I saw early on that they were onto something. And I think, obviously there's probably a lot of work to be done, but I think they're definitely on the right path. And I'm excited to continue to see where it leads and how we can rely on technology rather than, human subjectivity and error.
Thank you, Dr. Lindsay. That was a great introduction, and we are so blessed to have you on this podcast with us today. And all three of you guys, Ramon and I really appreciate your time.
Absolutely.
Kara and Michael, can you've mentioned, Kara, that, you've kind of shifted towards the AI and machine learning as like the foundation for mGenesis, but can you kind of give us some more background on exactly what the mGenesis platform is and how your technology works?
Absolutely. So I'm super thankful for everyone like Dr. Lindsay who paved the way for, IVF to be such a mainstream technology today that we all get to work on. And I think it's really exciting how we get to keep innovating in this space. And so really the core of our technology is evaluation of embryo health in real time. And so what does that mean? So we know that an embryo should be a living, growing organism. We know that they're using energy. We know that the cells should be dividing. We know that they should be differentiating. But this is not something that, as embryologists, we can see in real time. I think about it like if you have a weed in your yard, it might not have been there yesterday, but then you went outside this morning and it's 3 inches tall. And you're like, wow, that weed grew really fast. But if you laid in your yard and stared at it overnight, you probably would have never seen it grow. I feel like that's what's happening with these embryos. The changes are quite fast, but they're not fast enough to be perceived by the human eye and brain. And that's where the power of artificial intelligence and computer vision comes in. So we believe that video data offers more data than a single still image analysis, which is like, I think Michael and I talked about this in the early days. All the research on time-lapse imaging was really fascinating, but we didn't believe that time-lapse incubation was really practical and feasible for the livestock industry. So we were like, how do we shrink that down and create something that's more data than a single frame image, but not as cumbersome as time-lapse incubation? And that's where we landed on these 30-second videos of embryos. We also realized that the livestock industry still operates with very low margins, and that whatever hardware that we utilize to deliver the system to the field needed to be practical and affordable. And so the answer for that was really right in front of us. Every single one of you, I can imagine, owns at least one microscope. And I can also assume that you own at least one cell phone. And the camera in your cell phone is probably the best camera that you've ever owned in your life. And so we're like, okay, they have microscopes, they have phones. So we started by simply capturing 30-second videos with camera equipment and microscopy equipment that people already had. And for years, we actually just sat on that data. Machine learning models, they need to be taught how to learn things. You can't just give it data of an embryo and say, like, figure out which ones make pregnancies. And this was probably one of the most challenging parts of training these models. To teach them, we had to know which embryos made pregnancies and which ones that didn't. So people like Michael took videos of thousands of embryos that they had in their routine everyday practice, and then they would work with their clients to get either calving or ultrasound updates that we could use to say, hey, this model actually made a pregnancy, or this model did not make a pregnancy. Michael and I think we celebrated the first 500 embryos, even though that meant nothing for machine learning. I think we celebrated 1,000 embryos going to this data set. And it really wasn't until we started getting tens of thousands of embryos with labeled pregnancy outcomes into our data set that machine learning models could really do their job. So the machine learning, it would take this labeled data, so videos of embryos that made pregnancies or videos of embryos that did not make pregnancies, and it would mine these videos for patterns associated with embryos that make pregnancies and those that don't. And then once we started getting enough data to start seeing trends and then ultimately become really specific and targeted, we can show it a video of any embryo that's bovine from any equipment, and it will produce a confidence score from 0 to 100 of how likely that embryo is to make a pregnancy. And so now going forward, people can use this objective information to select which embryos they want to transfer, which ones they want to discard, and just make better and more data-driven breeding management decisions.
I have a question. So for you, Kara, and for Michael, I mean, and then I'm going to let also after you talk about this one, I'm going to let the Dr. Lindsay kind of bring his counterpoint on this topic. But how can mGenesis technology be applied in the field of embryo transfer? Meaning, am I receiving, for instance, if I'm transferring like, IVF embryos for X lab, and then I have a microscope, I have basically like my iPhone. So am I getting like a 10 embryos on that 4-well dish, and I'm putting my phone there and holding that phone for 30 minutes and then
30 seconds.
30 seconds, I'm sorry. And then is that like a machine going to just tell me which embryos your tool is going to just tell me each embryo to transfer that has the higher likelihood of making a pregnancy? Is that how it works? Or what are the practical implications of like, how am I gonna use that in my towards my clients to better the conception rates?
Absolutely. So we created a web-based platform. So in the browser on your phone, whether it's Chrome, Safari, whatever, you go to mgenesis.app. Here you can upload or record the videos of the embryos. You can have multiple embryos in each video. We just ask that they be in focus, not touching or overlapping, and typically at about 60 to 90x magnification. You record that 30-second video, and then immediately the machine learning starts analyzing those videos, and you get a report directly in that web-based platform. Ideally, the embryos should still be in the dish under the microscope when you receive these results. There will be a box around each embryo, which correlates to the scores. And then you get that embryo health score for each of the embryos that you just took a video of. And you can use that data to decide that, hey, today you want to transfer only the top 20% of embryos, or you want to transfer all but the bottom 10% of embryos. It's really your call, but we give you that score that helps you rank the embryos from most healthy to least healthy, and you can decide how that fits into your practice. And I think Michael can probably give more firsthand user experience on these things, but it was really developed to just empower embryologists with more objective data to make better decisions.
Yeah, I'll just touch base on the practical and the field side. Um, they, I've done up to 12 at a time, and it's 30 seconds. So I'm usually, I line up my 12, I can hit start, Meanwhile, I usually just record my stages and grades, for each one as I'm looking at them. And then, by the time I'm done recording my grades and stages, like the video's done, and then you can upload it real quick. And I go on to the next set because we know, we want to move fast. I go on to the next set, and then in the meantime, the machine learning and the system is running them, and you get scores back really fast. So, it really doesn't. There's been concerns about, like workflow and how fast you can do it. Like, it really, I don't really think it's minimal, for the benefit that it can provide. So,
We also believe that as technology advances, computer chips are getting faster. All those workflow issues that are present today are likely not going to be present in the future.
Got it. And Dr. Lindsay, what would be your concerns towards, like, basically that process in the field?
Well, just to touch on one thing real quick, I think I would, on a positive note, say, the one thing that is key with this technology is the aspect that it's non-invasive, right? Previously, we've had to rely on, terminal evaluation of embryos, such as staining embryos to total cell counts and inner cell mass to total cell ratios, and a lot of other, to tests that wouldn't allow us to keep, the embryo alive. But one of the things that we can do also is, with developmental kinetics, kind of correlate the data that, CARE's team with mGenesis is collecting, because that they're looking at a portion of that embryo's life as it develops. I remember a long time ago being very excited to see, I guess one of the first time-lapse videos I had ever seen, much less that was applied to an embryo, and it was fascinating. But I learned a long time ago, and this is to answer your question, that in biometry, which is the study of the statistical analysis of biological organisms, which is vastly different than hard physical sciences. So what I learned about this, and when I did my PhD, was we need to use much larger data sets, right, to get sample sizes large enough so that the power of the test is statistically significant enough we can make valid conclusions. It was maddening to me during the 80s when all these studies would come out, and I don't mean to bash theriogenology as a journal, but there's a lot of, journal articles with sample sizes of 20 and 30, which don't mean anything. But I think CARE's team, that they have understand this and are attempting to increase that data analysis, because right now we're at the beginning of this, trying to correlate, among diverse, individual data sets and trying to make broader conclusions. And so I guess that would be a question I would have back to CARE and the team, is how is that progressing? I know there's a lot of genetic variation within region, and breed types and all these things, and it has to probably play into account with your data.
Great question. Honestly, this would have been a whole lot easier had we developed a little box, put a microscope, lens, and camera in it, and really was able to standardize the environment that people took these videos in. But when we talked to people in the industry, they didn't want that. That's one more thing to buy. That's one more thing to haul around. They really wanted to use the microscope and the phones that they already owned. So, in business, I don't really believe if you build it, they will come. It's never been that easy for me. So it's really about product market fit. We had to understand the livestock embryology business and the types of technology that these people would actually adopt. And that's where my team has helped me. People like Michael, people like Dr. Russell Killingsworth, who have worked in this field, and they know what they would buy and they know what their peers would buy. And so we said, okay, we're going to try to make this work off of cell phones and microscopes that they already own. And in the early days of this, those variables completely turned those projects upside down. Like one camera might have a blue cast or a gray cast, and just the computer would get really confused whenever it saw these videos of embryos. Fortunately for us, technologies and artificial intelligence, they're becoming more robust. You know, your self-driving Tesla needs to be able to drive in the day and the night and when it's foggy outside. And so camera technologies are really getting a lot more robust to all these environmental variables, which we're definitely able to leverage when using this product. So now going forward, we've realized that we need these variables in our data set. So we try to take as many videos with as many phones as possible, with as many cameras as possible, with as many microscopes as possible. And sometimes we even take videos of the same embryos with different camera types so we can see the drift in the models as, you know, these embryos are exposed to these different variables. We have a really intelligent and amazing machine learning engineer who is accustomed to processing video data in real world environments. And so he's been able to do things algorithmically that can help adapt for these variables. I don't know that there's ever going to be an end date where we're like, we're done. I think this product is perfect. We're never going to evolve it after that. I think it's going to continuously being an evolving process. But when new people work with us, we say, hey, we want you to give us 30 to 50 embryos recorded on your system. That's going to be completely free of charge. And we want to use those videos that you recorded to help do quality control and help calibrate it. If we are confident that our system is able to get a good read on that system setup, then they can proceed and start using our analysis in their decision-making process. If not, then we'll just ask them to keep recording more videos of embryos and keep doing calibration on that technology until we can get a good read on them.
That's great.
Yeah, it's fascinating too. I love the part when you say, like, you know, we're never just gonna like be done and walk away and say, yep, this is finished, because, you know, that it's so cool to, you know, always just have a goal to always be bettering the product, bettering the industry's knowledge base and the technology that we have at our fingertips. So have you guys tested mGenesis against like experienced embryologists and see how that shakes out, like the machine learning system versus the human eye?
Yeah, so we actually have a couple different products. One is Easy Grader, which is just a machine learning based automated embryo stage and grade analysis. The exciting one that we're talking about now is Envision, which is the embryo health analysis, which goes beyond morphology. And we actually published a study last month in Journal of IVF Worldwide where we surveyed 42 embryologists at the IETS in 2024. We asked them to stage and grade these embryos and predict which embryos would make pregnancies. And then we compared those against our machine learning results. And we use those data for this publication. It was predominantly on the stage and grader because that's easier to make claims about and see. And our machine learning graded and staged embryos comparably to people with 10 years or more of experience, and then outperformed those with less experience. For the Envision, how we validated this is kind of like I said at the beginning, we didn't have anything for years. We needed the data to build this product. And so the embryologist would record these videos, transfer all of the embryos that he thought were acceptable, and then we use the actual pregnancy outcomes. So using that, we can now take the machine learning models prediction of those embryos and compare it against actual results so we can see how well these perform.
So is those
Go
data
ahead, go ahead.
sets, are those on fresh and frozen embryos both?
Typically, so our first product is for fresh embryos because most people do direct transfer. They don't want to thaw them out and look at them again. So our first products are available for fresh embryos at day 6 or 7.
Okay.
I have a couple of there. It will be like a combination of questions here, Kara, and then I'm also gonna ask Dr. Lindsay to jump in on this one here. But like when it comes down, for instance, to the applications of emgenesis towards like embryos. When we were talking about fresh embryos on of course flush and IVF, there's a little bit of a difference there. And then like does the environment, like for instance, are the embryos on a heated plate, on holding media X, Y, and Z, gonna change the evaluation? And has emgenesis also used the technology towards oocytes to predict also cleavage rates?
So we recommend that people do not change their protocols with the exception of taking a video of these embryos. So if you use a heated stage, we definitely recommend that you still use a heated stage. If you're just doing conventionals and are not working with a heated stage, and that's fine. And actually, when you upload the video, it asks you to report if the embryo is conventional or IVF, just so we can, help distinguish those differences if need be. But really, the only changes to your day-to-day operations that we're trying to initiate is that you add a video to this process. Oocytes.
Yes.
So we don't have much data at all from oocytes. I think theoretically it could be used to predict cleavage. And actually, I think there was a group in Sweden recently that published a Nature paper where they were looking at machine learning and application to bovine oocytes, which was kind of exciting. I would love to move us in that right direction. It just needs data. So if there's people willing to collaborate with us, I'd love to have that conversation.
What are your thoughts, Dr. Lindsay?
Well, yeah, she's addressing a lot of the questions I guess I had. But as I mentioned before, one of the first observations we realized when we started making IVF embryos is, these guys are different, right? And so you clearly identified that, trying to, I guess, develop a couple of different algorithms. And I guess my question is, are you finding that the machine learning it's easier for it to have predictability of embryo viability for an in vivo versus an in vitro? Because that's what I would expect. That's, when we look at, and there are some papers that published, some of these terminal evaluation techniques of embryos, and just morphologically, when you looked at them, it's like they look the same. But when you looked internally with, inner cell mass ratios and those kind of things, that no, these embryos were different. And I'm just wondering how easy or difficult is your algorithms, is it able to pick up that?
Great question. So today, our product is a decision support tool. It is not a diagnostic. And so what that means is it can recognize normal and it can recognize abnormal. So for example, if, I'm watching my horse walk to me, I can tell is she walking normally or is she's limping. And just, staring at her walking, I can't diagnose if she's limping. I can't diagnose what is wrong with her. Is it her knee? Is it her hoof? Does she have an injury? But I can at least say, hey, she's limping. She's not normal. She's hurt. It would take more advanced diagnostics to really go and look in the source cause. But functionally, normal embryos make pregnancies. Compromised embryos do not make pregnancies. So while it would be awesome to know, is that embryo genetically compromised? Does it have heat stress? What's wrong with it? We're not at that point yet, but if we can at least help you identify the healthiest embryos with a good chance of making pregnancies, and then the embryos that really don't have a chance of making a pregnancy, we feel like we are helping move that needle. So I do think with time, we can do more studies where we can become more of a diagnostic, but today it's really a decision support tool.
Okay, and just to add a little bit on Dr. Lindsay's questions, like if you have that has happened to me many times. I have 3 or 4 embryos on my plate, and then I know there's one that's like growing on holding media right there, and then the other 2 are not, growing and expanding. If I separate those embryos myself and I transfer them, and then the machine also does the same thing I'm talking about in vitros here. The likelihood of a human eye being as accurate as the machine on your data, how have you guys do you guys have any information, like on precise information on that? I know you said that the machine was better than people that had 10 plus years of experience, but have you actually compared, like Michael, for instance, sorting embryos versus the machine sorting embryos at the same time?
Yes, so what I think you're asking is how does it do on negative controls? And I've
Yes.
definitely asked, people to take videos of their grade 4s, take videos of their UFOs, take videos of these degenerates, because we need to train the model on those as well, because that's something that we will encounter in the field. And today it is very, very accurate in predicting and, determining that those embryos have no chance of making a pregnancy, correctly staging and grading them correctly, and getting that, accuracy down. So we've done a lot of negative control studies. We've also seen a lot of embryos that look beautiful and perfect, score low through our system. Even some people that have rolled those embryos, retested our system, they score low again. And then actually in practice, those embryos did not go to make pregnancies. So what's kind of fun about the system, so if we take out the machine learning, just quantifying the amount of activity in these embryos gives us a trend. So what we've seen is completely agnostic to embryo stage and grade. Embryos with high activity and low activity do not make as many pregnancies as embryos with mean moderate activity. It makes a nice bell-shaped curve. And like most things in biology, the embryos fall into this. Average is good, outside of standard deviations, either left or right, is bad. I've not proven this, but this trend really mimics the quiet embryo hypothesis, looking at embryo metabolism, saying that some of the embryos that are too fast growing and too metabolically active are actually burning through their energy stores and developing at a rate that's not sustainable with life. So they're burning themselves out. And so, like I said, without machine learning, we are already seeing these trends that give us some insights into what our assessment is looking at. When we give machine learning to it and we pair it with machine learning, we get to be even more targeted and specific with those outcomes and how we predict that.
That's awesome. Thank you. That's great.
Thank you.
Kelsey?
Yeah, so I kind of want each of you three to give me some feedback on this question. I think maybe Dr. Lindsay will start with you, but where do you see Genesis and just the whole technology platform that Genesis kind of stands on, heading, into the next 5 and 10 years from now?
That's a great question. It's kind of like, you're asking us to look into the future, and that's fine because I love those kind of questions. This machine learning aspect is one that I think will continue, for a while, because again, I think everyone understands now we've got to collect a lot of data to validate the models, and that obviously needs to continue. I do think there's some other maybe integrated technologies that could be run in tandem with this technology. I have to admit that I've only recently kind of reinserted myself into the looking at other technologies. I've recently got a new partnership with setting up IVF labs, and that is challenging me, I guess, in my thinking to look at things. And I think one of the ways that we might be able to do that, and it's similar to machine learning, but it's using actual AI technology to look at bigger statistical models. And I start getting out of my league whenever it's really been a struggle for me, coming from my era of child of the 60s to now start thinking about, okay, all these futuristic applications of machine learning or AI. We not just predicting stage and grade, that seems to be something that's fairly basic. We're looking at the embryo's ability. I think we got to stay focused on that for a while and predict embryo ability to not only we select it for its viability, but does it actually make a pregnancy? So that is a given. But also look at maybe because sire and dam factors get diminished once we have a viable embryo. But are we missing something by not going back and reevaluating sire and dam, influences on a larger scale? So it's almost like I think we have to revisit some of our old paradigms in terms of thinking that we know what we're doing, and it could go all the way back to how we set up the recipients. That's the next big factor, right? So that's one question I might still have for Kara is like, how is recipient being taken out of the model to evaluate predictability of an embryo's viability? Because it may not be the embryo's fault, right?
Can I step in on that one?
Sure.
To answer the original question, like where does this go in the next 10 years? I think a pretty simple approach is just collect as much data as you can on everything. So like a lot of the transfers in the data set I've done, and I actually manage the recips. And I mean, uh I have I'm working with a PhD at University of Wyoming to come up with a recip index, taking all this recip because you're right, like we know the recip is a huge factor. We know the weather and the environment's a huge factor. So going forward, one of my big goals is to make a recip index. We're going to start incorporating ultrasound um, reels basically here shortly. Um, like in the next couple weeks, we're going to start collecting data on that, that analyzes the ovary and the uterus, and then all the other recip factors that we can collect, days since estrus. I even have it down like we have iPads that we record everything on. There's like no more paperwork. Like I have it down to like I'm within 5 minutes of how long the embryo's been in the straw, because we do know that negatively affects it. So like I can get within like 5 minutes on that. We know that affects it. And then external weather, like this PhD from University of Wyoming is going to help us with it. So like that's that's one thing if I can collect it, that's one thing I can do to contribute is like I can measure a lot of this recip stuff and try to take that out of there, because we know we're transferring embryos into recips that aren't good. So that should help out the accuracy. We even have like genomics on the recips for how good a recip they have. So like we have a lot of data on the recip side that'll be really exciting to incorporate. And then you kind of stack all this stuff together, and who knows where it's at in 10 years. But I can't help but think, like we're going to drive that cost of pregnancy down. Um, every little bit we can improve will drive that cost of pregnancy down, and eventually the cost of that live calf down. And I think when we get that lower and lower and lower, that people, other producers, not just elite genetic producers, will be able to use IVF technology to improve their genetics all over the industry. And then what does that do to our industry? Like it's pretty exciting, like more milk and more beef, you know, with less resources. So like I don't know, it could be pretty cool. I'm excited about it.
Thanks, Michael.
I completely echo that 100%. And I think Genesis was not created to be a silver bullet. We said, hey, there's a lot of problems in the system. It can be environmental, it can be maternal, it can be embryonic. What are my skill sets capable of solving? So we focus on the embryo. So our technology is really evaluating the embryo, but I believe that it can be used as a complement to other technologies to look at recipient, environmental, genomic factors, etc. And then that's how we really move that needle to exactly what Michael was talking about with that more pregnancies, higher return on investment for the beef or dairy producer, and then ultimately that every embryo transferred makes a pregnancy that survives to term. It drives the price down and it makes more protein to feed more people more sustainably. So I think it's exciting. We've learned a lot. And I also think it's really cool that because we have a video database of so many embryos, if we want to go back and look at something retrospectively, we can absolutely do that. If we want to look at, the impacts of heat stress or weather or maternal environment, we're already sitting on that data to do that, and we can go back and look at whatever we want. So data is power, and it's super exciting to be innovating in this space.
Well, thanks again, Kara, Michael, and Dr. Lindsay for taking the time to walk us through this exciting embryo transfer innovation. This was a very, very exciting talk. I was, thrilled about it. And, once again, it was great. And that brings us to the end of another episode of AETA Talks. If you enjoy our show, be sure to like, subscribe, and rate us, and spread the word to a friend or colleague. We welcome all feedback at AETA@ASSOCHQ.org. Kelsey?
Yeah, we love the feedback. So please send it to us, guys. For previous episodes, show notes, or more about AETA, just please visit our website, aeta.org. And thank you guys so much, Kara and Michael at mGenesis for supporting this episode of AETA Talk by sponsoring, and then also with your time today and all of your expertise. And thank you so much, Dr. Lindsay, for being here with us today. I'm really excited to have you pioneers in our industry with us.
Thank you. It was very, very good. I enjoy it very much.
Thank you,
Awesome.
guys.
Thank you.